Hi everyone, welcome back to the coding series. Today's problem is isomorphic strings. Let's understand the problem statement. Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if the characters in S can be replaced to get T. Let's understand that with the example. I will consider the same example that was mentioned. So, given S is equals to EGG and T equal to ADD. Okay. Now let's check whether these two are isomorphic or not. Okay. Now in S, how many unique characters we have? We have only E and G, right? So if I map this E to A and this G to D, okay, that means if I am mapping E to A also should map to E. Okay. If I map to G to D, then D also should map to G. Because what if you go in the reverse direction? Now I am checking whether S is equal to T, equal to T after you replace these characters. Okay. But what if I go in the reverse direction? What if I check replace these characters, okay, these characters with these characters, whether I can form S or not? That means in that case, A should map to E also should map to A, G also should map to D also should map to G, right? Now let's see. Now EGG, okay. Now we are replacing E with A and G with D, ADD, okay. Now this ADD is equal to T, right? Can I say these two are isomorphic? Yes. Now we will check for this also, whether T equal to S or not after you are replacing. Now ADD, okay. A you are mapping to E and D you are mapping to G and D also G. Okay, that means this is equals to S. Yes. So these two are this S and T are isomorphic. Okay. Now that's what here they mention. All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. Like A can map to A, B can map to B. Now let's consider this example. So S is equals to F11 and B equal to, sorry, T equal to B23. So T equal to B23. Okay. Now, how many unique characters are there in S? We have only F and 1, right? So if I map F to B, that means in B also should map to F1 to 2. That means 2 also should map to 1. Okay. Now let's see. Okay. Now let's see whether these two are isomorphic or not. So after conversion, after you replace F with B and 1 to 2 and 2, you got B22. Okay. But that is not equal to T, right? Because here 1 to 2 is fine, but this last, this B to B2 are same, but here you are getting 2, but here it is 3. That means if you map 1 to 3, then that will be possible, but this will not be because you already mapped 1 to 2. So you can't map this one to another number, right? Another character. So that is not possible. So these two are not isomorphic. Okay. Now, let's see how we can solve this. We will solve this using hash maps. Okay. I will take two hash maps. Okay. One is hash map 1 and one is hash map 2. That means F to B. That means B also should map to F. Okay. That means for each string, okay, I will store these values and for this what will be the replacement. Okay. I will store that in the hash map 1. Similarly, for second string, for this what will be the replacement? For that I will store this. I will take hash map 2. Okay. Now, so we will consider this F11 and T B23. Okay. Now, before to this, okay, if suppose we have length like EGG, okay, suppose we have this string as EGG and T as some um, A, D, D and E. Okay, that means these two are some A, D, D and C. Okay, these two can't be isomorphic. Okay, even if you convert E to A, G to D, but these two lengths are differing. So even after you replace this with this E to A, G to E to A and G to D, okay, you will not still after this you will get when you replace E to G, EGG with ADD, that means E to A, TDD. So these two are not equal, right? That means this length should be equal. Okay. So when these two lengths are equal, then only you can check whether those two are isomorphic or not. When you're after you're replacing the characters. Okay. Now, first check will be if ln of s is if ln of s is not equal to sorry if ln of s not equal to ln of t, then return false. Okay. Now you have to, so next step is to store these characters in the hash map. Okay. Now let's check that. While storing only we will check whether those these two strings can be isomorphic or not. Okay. I'll explain you that. So for I is to equal to 0, I less than ln of s. Either you can take ln of t, ln of s, because anyway both lengths are equal. Okay. Now I plus plus. Okay. What you will do is first, okay, first you take two variables, original and replacement. Okay. So I'm just taking this one. So original will be s of I. For this replacement will be t of I. Okay. That means if you are I will write hash map 1 and hash map 2 and our s and t. S is equals to f11 p equal to 2 3. Okay. Now first you have to see whether this f is present in the hash map or not. So when I equal to 0, this won't be present. This f will not, because you have to If it is not, if this key, if f is not present in hash map, then you have to add and you have to assign that with the with its replacement. Okay, now for that what you will do, if comma okay is to equal to hash map 1 of hash map 1 of this original s of I. S of I is original. Okay, if it is okay, what you have to do, I'll tell you. Okay, if it is not, else you have to map that hash map 1 of original with replacement. Okay, in one iteration only you can add in both hash maps. That means now you have to similarly here for this. Okay, you will map. Okay, so in the first iteration f is not present, so you will map f with b. Okay, similarly you have to map b with f. Okay, so that will be same. If v comma okay hash map 2 of replacement, because here t of I is replacement, so that will be key for the hash map 2. Okay, if it is okay, I'll explain what to add. Else what you will do, so if it is else, then say they similarly hash map 2 of replacement will be original equal to original. So in that way you will map b to f. Okay, now you have to check. Now in the second, when I equal to 0, you will add these two. Now when I equal to 1, original will be 1 and replacement will be 2. Okay, so you will check whether 1 is present in the hash map. No, hash map 1, it is not present, so you will add that 1 into our hash map with its replacement. So with its replacement means 1 is 2. Now you will check this one in the hash map to whether replacement is present or not, because you are mapping 1 to 2, you have to map in the reverse also. That means 2 to 1. That means 2 to 1, because 2 is also not present in the hash map 2, right? So you will map that with the original is 1, so 2 to 1. Now when I equal to 2, we have 1. Okay, now 1 is present in the hash map. Yes, that means you have to check if 1 is present in the hash map means it should map. Okay, now what you have to check, if 1 is present in the hash map means now if if this v is not equal to replacement. Replacement means this one. Here you already map 1 to 2, right? You already mapped 1 to 2. Okay, that means these two are equal. These two, that means hash map of this one should be equal to this one, right? If that is not equal, if v is not equal to replacement, here in when I equal to 2, what is original? Original is 1 and the replacement is 3, right? So here you already mapped, since if this is true means you already have 1 with 2. That means you already mapped 1 to 2. That means you have to check whether now the replacement is equal to this one or not, this value, for this the value. Okay, so if v not equal to replacement, then you can just simply return false. That will be inside this if condition. Okay, that means here 1 is not equal to 3 because you already map 1 to 2, so you can't map with another character. Okay, so in that way you will return false. Similarly, you have to add here also, if v not equal to original, for replacement it will be original, then you can simply return false. So in that way you will check. So in that way, in the in the third iteration, you will return false. So these two maps are not isomorphic. Morphic. Now we will check S is equals to EGG and ADD. Okay. In the first iteration, when I equal to 0, you will map in the hash map 1, H1 and H2. H1 is hash map 1, E to A and A to E. Okay. Now in the second iteration, when I equal to 1, in the second iteration, you will map G to D and same D also G. This will be 0 and this will be 1. In the third iteration, when I equal to 2, since you already mapped G, so this condition will be true. Now you will check. Okay, you will check at that time what will be original. Original is G. That means S of 2. S of 2 means G, right? And replacement T of 2 is also D. Now this, because you will check whether G is present in the hash map 1 because original is G. Yes, okay. Now here V not equal to V. Here V is G. Sorry, V is D because you will get its value. Okay, that will be D. So here D equal to replacement. So this condition will not be true. Okay, this condition will not be true. Similarly, you will check for the second hash map 2 also. In that way, at the end, you will return just true after you iterate entire string. Okay. Now, if you think about time complexity, we are just iterating over one for loop, that will be O of n. And space complexity, since you are taking two hash maps to store unique characters, so in the worst case, if all are unique, okay, so it will be O of n. So time complexity is O of n and space complexity is also O of n. Okay, so now let's see how we will. Now let's submit that. So just I can initialize to hash map 1, hash map 2, and I'm checking whether both lengths are equal, and I'm just taking original and just add. If it is present, I will just check whether that value is equal to replacement or not. If it is not, I will just return. In the else, I will map that to replacement. Similarly for this. Now let's submit this. See, all test cases are passed. That's all for today's case. If you have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.